Living in the world without insight into the hidden laws of nature is like not knowing the language of the country in which one was born. The movement of the sun and other stars around the Milky Way's core, the motion of stars in other galaxies around their respective cores, the formation of the solar system, the continual motion of planets and smaller bodies around the sun, and even the arrangement of galaxies across space are all connected with locomotion. To understand the universe, therefore, one must first understand motion itself. Locomotion is as old as the universe. In the framework of this book, the very first activity of existence was motion, the first stir within the primordial state. Without locomotion, matter could never have aggregated to form stars or galaxies. No solar system could have taken shape, and no body could have begun its journey through space. Thus, the study of locomotion is the first step toward understanding the universe. But what does locomotion actually ask us to understand? Consider a pendulum. How does a pendulum work? Why does its period remain the same for pendulums made of cork, wood, lead, or gold, bodies of vastly different mass, yet change when the length of the pendulum is altered? And what is the relation between pendulum oscillations, freely falling bodies, and projectiles? Now look at water. Why do oceans have tides and waves while still water remains calm? Why does a mere breeze raise ripples on the surface of a pond? These are different-looking phenomena, yet each involves motion. The planets add another layer of questions. Every planet exhibits more than one kind of motion. It spins on its axis while revolving around the sun. What is the relationship between these two motions, spin and orbit? Why are the spins of different planets inclined at varying angles? Why do most planets move in the same general direction while a few show retrograde motion? Why are the heavy, rocky terrestrial planets found near the sun, while the massive gaseous planets are far away? Where did the comets, asteroids, Kuiper belt, and Oort cloud bodies originate? Why are cometary orbits so elongated? What causes all these differences, and can we truly know how the solar system formed? The same inquiry extends beyond our solar system. Is there a relation between one star and another, for instance, between our sun and its nearest neighbor, Alpha Centauri? Are all stars in motion, or were some once believed to be immobile? Is there a correlation between a star's mass and its orbital speed within the galaxy? Why do galaxies vary so widely in size and brightness? What determines the extent of a galaxy? And above all, are there definite causes behind these patterns, or are they merely coincidental? Until we can answer these questions, we cannot claim to understand our galaxy or the universe itself. Yet all these questions, despite their differences, are bound by one common factor: locomotion. Motion underlies every formation, every arrangement, and every observed regularity in the heavens. Why do planets move at their characteristic velocities around the sun? Why does the sun move within the Milky Way at its specific speed? Why does every star in every galaxy trace a defined path around its galactic core? What is the true nature of space and time, if both only reveal themselves through motion? In this book, locomotion is not treated merely as an effect. It is presented as the essential condition for all phenomena, the pulse of existence itself. Understanding locomotion, and the variables that generate and regulate it, is therefore presented as the way toward understanding how the universe was formed, and how it continues to evolve. In the chapters that follow, locomotion will be examined not as an abstract idea, but as a necessary reality, a phenomenon inseparable from matter, and the first act of the universe. The inquiry will trace its causes from the immutable characteristics of primordial particles, explore its measurable variables, and examine how these variables give rise to the physical structures we observe, from the swing of a pendulum to the motion of galaxies. Thus, before discussing the possibility of locomotion, we must first acknowledge its necessity. For without motion, there could have been no universe at all.